I want to start by showing off some weird stuff. So we've spent a few weeks now using all these features. We've learned about loops and functions and if statements, and we've used them and we sort of believe what they do. But there's some weird stuff that we can get away with because we haven't yet really understood what some of these features really do. And one of the big ones is, what is this? So when we talked about loops, when we talked about if statements, we talked about asking yes or no questions. And we sort of glazed over it after that point, and you probably picked up that calling it a yes or no question is a little bit patronizing, and that maybe there were some hidden depths to that. Maybe it's not just using the less than sign or something else. There's also this issue. So a couple of weeks ago when we talked about if statements and the modulo operator, we did an example where we walked through all of the values of x between 1 and 100, and for each one we printed out, is x a multiple of 7, is x a multiple of 3, is it a multiple of both, or is it a multiple of neither? And the way we solved this before is we used this nested if statement idea. We first checked if it's a multiple of 3, and then if it was, inside that if statement, we checked if it was also a multiple of 7. And maybe that structure was a bit clunky. Now, to be fair, if you like that structure, if you like nested if statements, there's no reason you have to use the format I'm suggesting here. But a lot of people were asking about this. Why can't we just use a single stack of if and else if to ask first, is x a multiple of both 3 and 7? Then, is it a multiple of 3 if it wasn't a multiple of both? And then, okay, what about a multiple of 7? And then finally, if nothing works, then I guess it was a multiple of neither. So that's one thing. And I want to cover this. People have asked, this is the hard part. We already know how to ask the question, is x a multiple of 7? We use the modulo operator. Is x modulo 7 equal to 0? And same story for x modulo 3. And this is one of those yes or no questions. Yes or no, is the remainder of x after division by 3 equal to 0? But quite a few people have already contacted me and asked, okay, so I want to ask in one yes or no question whether x is a multiple of both 3 and 7. I know how to ask those questions separately. Is there a way for me to combine them? And the answer is yes. And I'll show you the answer. Let's just set this up. So what I want to do is first ask each question individually. I want to ask, is x a multiple of 3? Okay, there's one question. And I want to ask the other question over here, is x a multiple of 7? But this isn't one single question, it's two. I need some way of combining these two things together. The real question I want to ask is it the case that x is a multiple of 3 and x is a multiple of 7? And it turns out we have this operator in C that lets us combine these things, and it's this, 2 ampersands. And it turns out that the reason that there are two of them is significant, and we'll talk about that. If you scroll down, it'll come up at some point in this set of lecture material. So we have this operator that lets us combine two different yes or no questions into one. And this is an operator that we call logical and. The word logical comes from the fact that these yes or no or true or false questions remind us a lot of prepositional logic, which we don't need to know very much about at all in this course, but that's where the name comes from. And the logical and operator strings together two yes or no questions into one, and the answer comes back as yes or true if both of the two questions had the answer yes or true, and otherwise it comes back with the answer false. Let's try running this. And we'll have to do a spot check. So let's see. 1 and 2 are a multiple of neither. 3 is a multiple of 3. 7 is a multiple of 7. That looks good. And there's 21. It is a multiple of both. It's also significant that I ask the questions in this order. First I ask, is it a multiple of both? And then if it is, I print that out. Then I say, okay, so it wasn't a multiple of both. Is it a multiple of just 3? You might notice it's a good experiment to try. If I didn't ask them in this order, it wouldn't work. If I started by asking, is it just a multiple of 3, then of course I would just get inside the if statement and I would never evaluate any of the other mutually exclusive cases. So there's the punchline up front. Clearly there's something more to these yes or no questions than just the less than sign or the equal to, or asking if things are equal or not equal. So then the question is, okay, what really is going on here? What are these things? What exactly can I put inside an if statement? So we're back to this. What is the meaning of this yes or no or true or false question? And it turns out the answer is both sort of unsettling and, in a sense, profoundly beautiful, which it turns out that actually the less than sign or the equal to sign is no different than a plus or a minus. It's just one more operation that you can do in C with numbers. And so it turns out when an if statement is run, what it really does is evaluate a numerical expression inside the brackets. And if that numerical expression comes back with a number that is 0, then the question came back with the answer no. If that numerical expression comes back with any other value, 1 or 5 or 40,000, then the answer to the question was yes. Let's just try running this, and I can illustrate my point. Oh, whoops, this is the... Okay, so here, A is less than B. So I get inside the if, and so it prints that out. And just as a spot check, let's verify that it doesn't work if I ask a question whose answer is no. Okay, inside else. But really, what happens inside these brackets, this yes or no question, doesn't necessarily actually have to be a yes or no question at all. It can be any number. I can ask a strange question like if A plus B. Because all that really happens in C when you evaluate an if statement is you work everything out, you get a final number, and my drawing is misbehaving here. You work everything out, you get a final number, and then whether or not that number is 0 determines if the if statement is considered to pass or not. So here we've got 6 plus 10. Looks like the drawing's working again. And so the value that's inside the if here is the number 16. And all C ever does is ask, is that 0? If it is 0, the answer to the question was no. If it isn't 0, the answer to the question was yes. And so, of course, the number 16 isn't 0, and the answer to my yes or no question was yes. So let's try that out. Let's save it first. So as usual, we only got about 6 minutes into the video before I started complaining about my drawing program, as per tradition. So here it says inside if, and that's because this was considered to come back with the answer yes when treated as a yes or no question, because C has a pretty primitive way of handling that. Any number equal to 0 is considered to be an answer no. Any other number is considered to be the answer yes. So I could try something like this, if 0. And we'll notice that because that is treated like the answer no or false in C, so these warnings are irrelevant because I'm not using the variables, we end up inside the else. So that's weird, but it's also sort of liberating because it means that these yes or no questions we've been asking are really no different than using operators like plus or minus. And what we're going to begin studying this week is the idea in general of an expression in C and all of the different strange operators that are available. So let's take a look at one. So if it's true that yes or no questions are just numerical expressions, then can't it work the other way? If I can put A plus B inside an if statement, can't I similarly ask a question like is A equal to B or is A less than B and then store that in an int? And the answer, it turns out, is yes. It turns out that the less than operator and the equal to operator just create an int result, which means we can use it. So here, 6 is less than 10, which means the answer to this question is yes. Let's take a look at what comes back. Let's clear this. And z equals 1. And it turns out that these operators that ask these yes or no questions will produce either 0 or 1. 0 is false, 1 is true. Now in C, any number that isn't 0 is considered true, but the operators that concern themselves with just asking questions only ever give us a 0 or a 1. Let's ask the converse question, is A greater than B? Okay, and in this case, z comes back with the answer 0. And this means we can get away with a lot of very strange stuff. So for example, I can begin combining together these relational operators or comparison operators like less than with regular arithmetic. I can ask things like, what is 10 plus 5 times this? and we work it out just like any other expression in any other assignment statement. So we'd say, okay, so we've got 6 less than 10. Okay, the answer to that question is 6 less than 10? The answer is yes, so we get a 1. Okay, so what's 5 times 1? Well, that's 5. This is an ugly looking thing. 5 times 1 is 5. What is 10 plus 5? That is 15. So we expect Z to have the value 15. And we save the file first. Anticlimactically, Z comes back with the answer 0. We'll try that one again. Okay, Z now has the answer 15. I won't edit that out. You deserve to watch me fail. Remember to always save your files or you're going to be disappointed. So here Z has the value 15, and we've done something really bizarre. And unfortunately, it gets weirder. And the reason it gets weirder, so the reason this is weird is that we're using the comparison operator less than in the same sentence, in the same expression as multiplication and addition. That's weird. But it turns out we can interleave any sequence of operators in C that we want, and we have to know how they all work together. And there are a lot of operators in C, not just addition, subtraction, multiplication, division, and these comparisons. It turns out, in fact, that even this thing is an operator, the equal sign, the assignment. And we're going to see over the course of this week's material that that's a bit of a big deal, and we need to know how to handle that.